especially for upper Indus Basin. Now I will request our second speaker is Dr. Wen John. He is currently working as a professor in School of Atmospheric Science, CUIT, China. And Dr. Saab has served as the director in the key laboratory of land surface process and climate change. So today he will share his experience by the experimental study and the data analysis of hydro-metrological process over the source region of 3 rivers. So with this, I request Dr. Wen John, so please share your knowledge with the participant. Dr. Wen John.
Okay, can you see my PPT?
Not now, sir.
Not yet.
Not yet. I try again. Whoa. Still not?
Still not.
Still not.
Oh.
Dr. Ghulam Rasool is requested to unshare his slides. He has unshare. I think Dr. Ghulam Rasool's slides are shared.
What about now?
Sir, you unshare your screen. Dr. Ghulam Rasool is requested to unshare his screen so that Dr. Yen.
Yes, I have done.
Yes.
Okay.
Okay, it comes now.
Now it's visible.
Sorry for that.
So it's come?
Yes, it's okay. Thank you.
Can I start now?
Yes.
Okay. Hello, good afternoon, ladies and gentlemen. First, I think I would like to thank Dr. Mudasa Iqbal invited me to the seminar. He is my PhD student in China. We stayed together almost for 4 years, so it's a really happy period for me. And thanks for your staying. It is really my great pleasure to be here to introduce my research. I'm Jun Wen from the Chengdu University at Information Technology. It is in the northwest China, also in the downstream of the Tibet Plateau. Today, the topic is the experiment study and data analysis on the hydrometeorology process over the south region of the 3 rivers. So my talk have the following 4 aspects. So first is the background and the key scientific questions. And from this map, we can see the land atmospheric interaction and hydrometeorology process in the Tibet Plateau is linked to the most weather system in China from the Pacific and the Indian Ocean. So the research of the land atmospheric and the hydrometeorology process in the Tibet Plateau is very important. And from this figure, we can see the land atmospheric interaction and the hydrometeorology process are inhomogeneous because of the land surface type. This difference might cause the anomaly of the atmospheric circulation and result in the drought or the heating wave or even snow disaster. So what is the current status of hydrometeorology process in study in the south region of the 3 rivers? So under the global warming background, the air temperature increased and the precipitation fluctuated while the runoff go down obviously in the south region of the 3 rivers. And this implied that land atmospheric interaction and hydrometeorology process are not well investigated because of the changing land cover. So are there any linkage between the left and the right? So to explore this mystery, I propose the following two scientific questions. So the first one is, how is the hydrometeorology process in the south region of the three rivers? And the second is, what is the impact and response of the hydrometeorology process on the regional climate change? So to answer these two questions, I would like to talk the ongoing field experiment we are conducted in the south region of the three rivers. So the field experiment was conducted in the south region of the three rivers on the different land surface type. There are many advanced instruments was deployed in this experiment, such as the L-bed radiometer, is ground-based, also the Cosmos and the AD caravans and many other soil moisture. And some stations are equipped with a boundary layer meteorology tower. And it's in the different land surface types, such as grassland, wetland, also the lake surface. So all the land underlying surface suffered the frozen thawing process because it's in the Tibet Plateau, air temperature and surface temperature is very low. And we set up the observation at the lake surface, and also in the grassland, and also in the wetland. We can see some instruments such as AD caravan system, boundary layer meteorology tower, and others. So this is really important. For the soil moisture network, for the soil moisture observation, we have great contribution to the International Soil Moisture Network, which provide data for sharing with other scientists over the world. And we have three networks. There are Maqu, and Ali in the Tibet Plateau. So let's first look at the Maqu soil moisture network. So it's in the east part of the Tibet Plateau, and about 25 sites are installed. So sensors at 5, 10, 20, 40, 18 centimeter depth. It's covered about 160 square kilometer area. And observation is started from 2000 till now. It's a special design for validation the smooth and SMAP satellite product. And we also have the AD caravans and the automatic weather station in this network. And the central Tibet Plateau is cold semi-arid regions. So we have the soil moisture observation network, boundary layer meteorology tower, and AD caravan system. So it's covered about 40 by 30 square meter area. And also from those photos, we can see it's really hard work to maintain such a observation system in the Tibet Plateau. Sometimes when we go there to collect data, we just see cables and sensors are gone. So sometimes we have make the secret mark for each site to identify the site. Otherwise, next time when we go there, we cannot to collect data. We cannot see the instrument or sensor again. And the East Tibet Plateau is humidity, but the West Tibet Plateau is dry. So so we also do the soil moisture in these regions. So it's in a high cold arid region. So we have two network. It's a Shiquanhe and Ali network. It's covered about 40 by 30 square meter and 15 by 15 square meters. And the ground-based remote sensing is most field experiment in the south region of the Three Rivers. We have the L-bed radiometer, which we have cooperation with the European Space Agency, and also we have the Cosmos sensor for detect regional soil moisture, AD covariance system. So all those systems was designed for validating the smooth and SMAP satellite for the frozen soil process. So the purpose of those experiments at the site scale is for the analyze the soil moisture and soil frozen soil daily cycle. And the regional is for validating soil moisture distribution and soil frozen soil process. For the peak soil scale, such as 100 by 100 square meter, is for validating remote sensing product or develop algorithm. So all those observations are especially suitable for monitoring soil freezing soil process because it's a typical character in the Tibet Plateau for soil and land surface study. And this is a bird view picture of the station. So we can see we have the solar panel, soil temperature, soil moisture observation system, radiometer. Also we have radar, Cosmos, automatic weather station, snow depth, rain gauge, and AD covariance system. So this is a really great platform for do the land surface and the satellite remote sensing research. So in the third part, I would like to talk about the preliminary result based on our field experiment. So the first one is the application of land atmospheric interaction experiment dataset. So in the after we analyze the collect data, we found the soil hydraulic conductivity is different from the model default. So we have developed a soil hydraulic conductivity parameterization scheme for this region, and we use the new developed parameterization scheme to the simulation, and this is the intercomparing at the different depths, and the blue line is the model default parameterization scheme, and the green line is the improved scheme simulation, and the red line is the observation. We can see that after use the new improved parameterization scheme, the simulation is much close to the actual ground observation. We also analyzed the soil heat flux in the wetland and found that soil temperature and soil moisture have the special character. That means in the frozen period, this was very steady. This is the temperature, this is the heat flux. But after it's completely frozen, there is have daily cycle again. So we developed the algorithm for calculate the heat flux by considering the storage term and the soil latent heat terms. So this is the comparison with the without consider this way. This is after consider storage term and soil latent heat term. So we can see after consider these two terms, the calculation result is much close to the actual ground observation. So this is the application of the soil moisture network, and we use the Acer satellite data and develop algorithm for calculate the soil moisture. So that from those two figures, we can see the ground observation and the satellite remote sensing estimate are very agreement to each other. We also validate the small soil moisture product. and select 2 validation sites. One is our Maqu network in China. The other one is in the Netherlands, in 20 Netherlands, because we have a cooperated project each other. And this is a time series of the ground observation and the and the satellite product. We can see generally the satellite soil moisture is lower than the ground measurement. This is because of the scale effect. Now let's look at the evaluation of ECMWF soil moisture on the Tibet Plateau. From this figure, we can see in the growing season, the model simulated at ground measurement is quite agreement each well. But in the summer period, in the winter period, the difference is very big. So this reminds that the soiling process is not well addressed or needed to be considered in this model. So the ground-based experiment is mainly for monitoring soil free soil process. Many advanced instruments are developed, air-bed radiometer, and also we have the soil temperature, soil moisture profiler, and micrometeorology observation data. And from this figure, we can see that soil freezing zone process can be clearly identified by the observed brightness temperature, also the polarization ratio. So we can see when it starts, when it starts of the sowing process. And the microwave radiometer measures surface brightness temperature. So it's a flowing soil indicator, and also can be simulated by the numeric model, which can be used to develop algorithm for satellite remote sensing. So this is the blue one is a observation of the radiometer, and the red one is a model result. We can see in the winter, the brightness temperature is high, and in the spring or in the autumn, it's different from the winter period. And in this subsession, I would like to talk about hydro-metrology process over the south region of the process, over the south region of the rivers. And from this map, we can see the south region of the 3 rivers is located in the Asia water tower area. So it provides water for the East and South Asia region areas. So the hydrometeorology process in this region is very important. And this research was conducted by the Dr. Mudesa Ikbom. So this region have the 4 sub-basins. So the first one is the Huanghe, it's a headwater region of the Yellow River. And the other 3 are Jimei and Maqu and Tangnanhe. Also from this figure, we can see the percentage of the flowing soil to the sub-basin is decreased. And this is of the hydrometeorology variable. And from this figure, we can see the runoff decreased 36 cubic square meter second per decade, but not significant. It has a general decreased trend, but at the last 10 years, is present an increased trend. And this is the precipitation is decreased at 3.6 millimeter per decade, but not significant, we can see. And the air temperature exhibits a clearly increased trend. So it's in this region, the air temperature is really get warm. And in order to separate the climate and the land cover impact to the runoff, we use the SWAS model to do a simulation, and also we use the SWAS model was run at the river basin scale. We also use the atmospheric soil property and other land use cover information as the forcing data. So this is the simulation. We use the ground observation to calibrate the model simulation. So we use the first part as a calibration and use the second part as a validation. So the result is that its determined coefficient is very high, and also the Nash start cliff coefficient is more than 0.7, and also relative the bias error is very low. And to separate the impact of climate and the land use on the simulation of the runoff and the evapotranspiration, we designed 4 scenarios. The first scenario one for the climate is from 1976 to the 1995, and the land use is 1990. And scenario 2 is climate is from 1976 to the 1995, and the land use is 2010. And scenario 3 is for the 1996 to 2040, and land use is from 1990. And scenario 4 is climate is 1996 to the 2040, and land use is from the 2010. So the result is listed in this table, and the conclusion is that change of the runoff and evaporation is dominated by climate change, not the land use cover change. You can see from those figures. So finally, we arrived at a conclusion of the prospect part. So the main contribution of my research is to explore the land atmospheric interaction in the south region of the 3 rivers, and to improve the parameterization schemes for land surface model, and also to develop or validate the remote sensing algorithm and the product, and to monitor frozen soil process in the Tibet Plateau, also to understanding the hydro-metrology process in the river basin scales. So with the support of those research, I co-authored more than 100 publications or the patents, and granted more than 10 million Chinese yuan research funding in the past 10 years for my research group. So I would like to conditional sharing all those data in the future. And also I hope to develop cooperative research partnership with interesting scientists by cooperative project, sharing or set up field stations, because to share the data to do the research is really important for improved understanding. So that is all my talk. Thanks a lot for your listening.
Thank you very much, Dr. Wen Yon, for your nice presentation. Dear participants, this is the end of our first session. In first session, we had 2 speakers. First was Dr. Ghulam Rasool. He was talking about the impact of the climate change on water sources of Pakistan. And Dr. has rightly pointed out that the glacier melt is at very rapid rate, and alarming situation is that we are going to lose 1/3 of the glacier mass at end of this century. And based on his experience, he also pointed us that the monsoon pattern in Pakistan has drastically changed. So we have more extreme events, and there are more flash flood, and for water resources management and conservation, we have to build large reservoir to manage the water for dry period. One thing which was very good for, that was also information for me, that the black carbon deposit on the glacier, they are accelerating the glacier melt. So that's all. Thank you very much. We have to monitor the black carbon depositing and the melting rate, and how we can manage the water in the water hour in future. Our second presenter was Dr. Van John. He has worked on in the field of Tibetan glacier. Dr. Saab, it's very difficult to work in the field, especially in the glaciated area, where you install the instrument and after the snow on the glacier, when you go back, and sometimes you could not find any data, even the instrument may have been replaced. So your finding that was very good, that the runoff and the evapotranspiration is changing, and this is mainly dominated by the climate change. So it's a reality that the climate change is impacting all the aspects of life, especially the water resources. Thank you very much, sir, for sharing your data and coordinating research with other organizations. As Center of Excellence in Water Sources, we are dealing with the water sources management, modeling. We have been using SWOT model for different studies. And we are more than happy to coordinate with you and work with you in future with a similar study. So thank you very much for this. Now we will start